Ladies and gentlemen, boys and girls, today is another day that I want us to handle a concept that we all know, but somehow some calculations brings us problems. We all are aware of earthquake. Earthquake is simply caused by release of energy that happens between the tectonic plates. This energy is what comes out in form of waves. Now these waves are what we call the seismic waves. We have two types, the body waves and the surface waves. Body waves take place within the Earth's structure, while the surface waves takes place on the surface. So today I want us to restrict ourselves to types of the body waves. We have two types. We have the primary and we have the secondary. As you can see from what we have, the primary waves are longitudinal, causing rarefactions and compressions. They are faster than the secondary waves. Primary waves can travel through solids, liquids and gases, and are the first to be detected by the seismographs. We also have the secondary waves that are transverse in nature. In other words, the travel of particles are perpendicular to the direction of propagation. They are slower than the P waves. We have other waves, but today I want us to do some mathematics concerning these waves. I want us to look at a typical question on waves. The figure 5.1 represents a seismic wave produced by an earthquake. State whether this seismic wave is a P wave or S wave. This is a primary wave. Reason, it is longitudinal. You can also say it has rarefactions and compressions. This region represents high energy, while this region represents low energy. So we are saying that rarefactions are for low energy while compressions are for high energy. Now, part 2 of the question. The wave represented in figure 5.1 has a wavelength of 1.2 times 10 power 4 meters. Calculate the actual distance between J and K. One thing we must note always is that the wavelength is given from midpoint of a compression to another compression, or midpoint of a rarefaction to another rarefaction. In our diagram, we have from J this another midpoint, this another midpoint. So from this to that we have a wavelength. From this to that we have another complete wavelength. So if we take from J to K, we find we have 1.5 waves because this is the midpoint. This is half of a wave. Therefore, we ask ourselves, if one wave is 1.2 times 10 power 4, what about 1.5 waves? We say times 1.2 times 10 power 4. If you calculate this one, we shall get 1.8 times 10 power 4 meters. You can also write 18,000 meters. Some can also write 18 kilometers. All are right. The next question. The wave in 2 travels through the ground at a speed of 4,600 meters per second. As the wave passes a certain point, the ground completes 5 oscillations. Calculate the time that it takes for the wave to pass. Show your working. Speed is V. V is 4,600 meters per second. Oscillations are 5. However, we know the wavelength as 1.2 times 10 power 4 meters. We know the equation V is equal to lambda f, in which f frequency is same as 1 over t, the period. So we can say that V is equal to lambda over t. Then when we make t the subject, we shall have lambda over V, which is equal to 1.2 times 10 power 4. And since there are 5 oscillations, means 5 complete waves all over, velocity is 4,600. If you calculate this one, you will get approximately 13 seconds. So for one wave, we shall have 13 over 5, which gives us 2.6 seconds. And that is how we solve such questions. For more of such tips, revision when it comes to checkpoint, IGCSE, A levels, AP, SAT American curriculum, don't hesitate to reach us for a one-on-one treatment or guide. Thank you and have a nice time.